as just we started we did this in last class. Smaller atoms. How do you write the electronic configuration of smaller atoms? And I told you that smaller atoms are considered to be less than 20 electrons. They're smaller. And what you're going to do is you're just going to write 288. Forget 218, 32, and 50, and so on. Because 20 electrons, you don't need that many shells. So 288 करके काम चल जाता है. So you just use 288. So I'll just draw a few small atoms. Let's try to do sodium. Okay, we'll move on from there. So sodium is 11 and 23. So that means it's got 11 electrons and it's got 11 protons. And it has 23 minus 11, that's 12 neutrons. Okay? And the electronic configuration is going to be 2 in the first shell, 8 in the second one, and 11, that means 1 in the last one. So it's going to be 281. Sodium would look like this. It's going to have 3 shells. And since it's got 3 shells, it will have, it's going to have, so that's 3 shells. The protons and the neutrons are over here. That's 11 protons and 12. As you got 11 protons, 12 neutrons in the center, or 281. That's 2 electrons. Okay, make sure you draw them in pairs. 2, 8. And then there's 1 electron, right? So that's 281. So that's sodium. If you want to do any other one, that's you can do fluorine would be 2. Fluorine kya hoga? Fluorine would be, I gave you fluorine as well. That's 1 second. As I gave you fluorine as well, that's 9 and 19. The smaller number is the number of protons and it's the number of electrons, and the difference is the number of neutrons. So 9 electrons would be 2 and 7. So if I draw fluorine, it's going to have 9 protons and 10 neutrons in the nucleus, and it will have 2 shells. So that's shell number 1. And then there is shell number 2. So it's sorry. So it's 2 electrons and 7. And 7 electrons. You get 2 and 7. That's about it. So remember, okay, first smaller atoms. Remember, first 20 electrons. Atoms up till 20 electrons. Just think of it as 288. That's it. You don't need 32. You don't need 50. You don't need to know that the third shell has 18. Because you don't have that many electrons. And I also told you that smaller atoms are the ones that are more common. Bigger atoms are unstable in the universe. Most of the universe is just smaller atoms. Most of the planet is just smaller atoms. The first 20 elements, and that's mostly most of the atoms that you're going to see off. So 288 is fine. But make sure that you keep this in mind. Okay, the actual number is 18. The actual number in the fourth shell is 32. In the fifth shell, it's 50. Okay. We'll move to bigger atoms in a short while. I'm going to jump to. Actually, is that clear? And otherwise, it's clear. Everyone else.
Yes.
Okay, so we'll now going to jump to ions. So what are ions? remember, electrons can be lost and gained. Electrons are on the outside, right? Somebody's going to come and steal those electrons. They're going to get knocked out. Remember, these atoms are basically bumping into other things. I mean, there are atoms all around you. They're constantly bumping and colliding with everything else, right? So the electrons on the outside, they can be lost. They can be gained as well. So ions are formed when you have an unequal number of. So due to an unequal number of electrons and protons, so due to an unequal number of electrons and protons, the atom gets a net negative or positive charge. Or an overall negative or positive charge. And because of that, N becomes an ion. What do you call it when it gets a positive charge? What name is given to that particular ion?
Or negative.
If it gets an overall, if there's an atom that gets a positive charge, what is that called? I mean, there's a word that's used for it, and that's called a cation. And vice versa, if it gets a net negative charge, then it's called an anion. So you've got two types of ions. You've got cations and you've got anions. So let's discuss this. So if there's a sodium atom, we already drew sodium, right? So I'm going to draw this again. I'm just going to copy this. So if you've got so if you've got a sodium atom over here, and that's the electronic configuration. Somebody comes and steals that one electron, right? So that one electron on the outside is gone. So this one electron over here is lost. It's gone. So there's one electron less. Instead of 11 protons, it's got 10 electrons. What do you think will happen? Will it get a positive charge or will it get a negative charge? Sorry, wrong. Just a second. One electron is lost. क्या होगा? Will it be a positive ion or a negative ion now? Anyone?
Negative.
So remember it's lost an electron. So will it be positive? It's going to be positive. Why? Because when it loses an electron, what is the composition of the atom now? It's 10 electrons. So that means it's got a charge of minus 10. But it's got 11 protons. So it's got a charge of plus 11. So what's the total charge on this thing? The overall charge is now this more positive charge. So the overall charge is plus 1. So this entire atom now, once it's lost an electron, so when the electron is gone, there's nothing there in the outer shell. So that's gone because there is nothing there. So this entire atom now has a charge of plus 1, and this is how you're going to write it. You're going to put brackets around it and you're going to put plus 1 around it. So that is what sodium looks like. So remember this, if an atom loses electrons, it always gets a positive charge because once it loses electrons, the negative charge is going to be lesser and the positive charge is going to be greater now once it loses electrons. So loss of electrons makes it more positive. So when something loses electrons, it becomes positive ions are going to be formed. Is that clear?
Yes.
And vice versa, what if an atom, I'm going to take the fluorine atom now. What if an atom ends up gaining electrons? As we'll discuss later why they end up gaining and losing electrons. But so let's say I've got fluorine now. So what's the issue with fluorine now? It's let's say it gains 1 electron. So instead of 7 electrons, it now has 8 electrons. So in total, in the outer shell. So in total, it has now 10 electrons. So it has gained an electron. So there's this one extra. So you got this one extra electron. So what is the overall charge now if it has gained electrons? Negative or positive? क्या होगा इस case में?
Negative.
Negative, right? Because you got less positive charge in the nucleus, that's 9 protons, but you got 10 electrons, that's a charge of negative 10. So the overall charge is now -1. So it's going to be negative now. So it's going to be -1. So gain of electrons always leads to the formation of a negative ion, right?
Yes.
So remember that. Another way to remember this is remember this thing always that remember atoms can always, you got outer shells, right? Atoms can always gain electrons, they can always lose electrons, right? So remember this, that when you're gaining electrons, you're becoming more negative. When you're losing electrons, you're becoming more positive. So if you think of charge as a number line, okay, this is going to come in very handy. If you think of charge as this number line, right? And so this line over here represents charge, and it's got numbers over here on top of it. So that's 1, 2, 3, 4, 5, 6, 7, and so on. So let's say that's 0 in the middle. This is +1, this is +2, this is +3, this is -1, this is -2, this is -3, right? So if you're heading in that direction, if you're heading in this direction, that means you're losing electrons. I'm talking about the overall charge. So whenever you lose electrons, you become more positive, right? So you go from +1, you lose another electron, you go to +2, you lose another electron, you go to +3, so on. And whenever you gain electrons, you become more and more negative, right? So if you keep on gaining electrons, you're going to become more and more negatively charged. So you might go from +1 to 0, that's a gain of electrons, 0 to -1, that's a gain of electrons, -2, that's another gain of electrons. So you keep heading in that direction, you're continuously gaining electrons. You're getting more and more electrons around you. Is this clear, this thing? You clear?
Yes, sir.
So tell me one thing. What's so let's write down a few electronic configurations. I've got Al, which is 3+. This is Al's numbers around it, 13 and 27. So first thing, how many protons does it have? Aluminium. क्या होगा?
13.
Here you got 13 protons. Remember, the number of protons never changes. I told you in the last class that every element, I told you in the last class when we were doing isotopes and specifically elements, I told you that every element, just hold on a second. So this one. I told you that elements are identified by their proton numbers. The proton numbers always remain constant, right? So an element will never lose or gain protons. That's a constant. So aluminium over here will always have 13 protons. So how many electrons will it have?
Electrons also 13.
So it's going to have 13 electrons, but it's got a +3 charge. What does that mean? Has it lost electrons or has it gained electrons?
It has lost electrons.
Right, so it's lost electrons. And how many electrons has it lost?
3.
3.
So that means it's got 10 electrons, right? So it's not going to be 13, right? It would have been 13 if it had been an atom, a neutral atom, right? If you become more positive, you're losing electrons, right? So so the electrons are 10. Neutrons, neutrons is the difference. Is 27 minus 13. That's what do you get? 14.
Yep.
Okay, so that's aluminium. Let's do another one. We have oxygen, which is 8 and 16 and 2 minus. So how many protons does it have?
8.
Okay, you got 8 protons. And how many electrons?
10.
10. It should have had 8 electrons, but -2 means it has gained 2 electrons. Instead, it now actually has 10 electrons. Remember, negative, that's gain of electrons. And neutrons, that's difference. That's 16 minus 8. That's also 8, right? So that's what an ion is. And whenever you're going to draw an ion, remember to put brackets around it. If I want to draw this thing, okay, here's how I'm going to draw this. It's got a nucleus, okay, which has 8 protons and 8 neutrons, and it's got 2 shells around it. 10 electrons. How are 10 electrons distributed? That's 2 and 8, right?
Yes.
So I just need 2 shells. So I got the first shell, and I've got this second shell. So I've got 2 electrons, and it would have been 6, but it has gained 2 electrons. Usually the electrons gain are written with a different symbol. We'll come to that later on, but so I've just drawn them in blue. And the overall charge would be minus. It's going to be -2. Okay, or 2 minus. Okay, it's the same thing. You won't lose marks for that, but it's better to write minus after the number. That's the convention. So anyways, that's what an oxygen would look like. Now it's an ion. Is this an anion or a cation? Kya cheez hai ye?
Anion.
Because it's an anion. Negative ions are, remember, anions. So this one is an anion. Okay, that's your anion. As anyway, so that's about electronic configurations. TK will do more of the ion stuff when we do ionic bonding, but remember this part that what happens when you have a positive charge? What happens when you have a negative charge? So I want to do the electronic configuration of bigger atoms, but before moving on, remember it's time consuming. Writing electronic configurations is kind of time consuming. And remember, most chemical reactions are basically water. They're basically the outer electrons. Sometimes an atom is losing electrons, sometimes it's gaining electrons from somewhere. So all chemical reactions are basically this happening, that someone steals an electron from someone else. So most of the chemical reactions around you, it's just that. Like if paper catches fire, what is happening? There's an oxygen atom that's coming in, and there's molecules in the paper, and they sort of start the oxygen starts gaining electrons from the atoms in the paper. So it's basically electrons being transferred from one atom to another one. But moving on, still sticking to electronic configurations, but slightly moving away from this at the moment. Electronic configurations, there are other easier methods of writing electronic configurations. And because remember, everything has to do with electronic configurations. We can't just every time start writing protons, neutrons, electrons. We have to be more direct. So I'm going to link the electronic configurations with the periodic table. And where's a periodic table? There was a picture of a periodic table somewhere, just like in this one. So let's take this image. Now, the periodic table is divided into two things. Does anyone know what those two things are?
Non-metals.
अच्छा वो तो एक है. What do you call this thing?
Alkali earth metals.
That's also true. But what do you call the vertical column?
Group and periods.
Okay, so that's your group. So this one is a group, and then you've got your periods. Here, this horizontal row is your
Periods.
so those are your periods. Now, what information does your group give you about the electronic configuration?
It gives the valencies.
Okay, so it tells you the valence shell electrons. Valence shell means the outermost, like anything that's in group 1 will have 1 electron in its valence shell. So the group numbers are given at the top. So group 1, all atoms will have 1 valence electrons. So they're all going to have 1 valence electron. And so the group numbers are given over here. That's 1, 2, 3, 4, 5, 6, 7, and the last one is 0. That's a noble gas. That's also a group. The middle part is your transition metals. The proper word is D block elements, but so those are your transition metals. So the group number gives you the number of electrons in the valence shell. So anything that's in group 1, like lithium, what's the electronic configuration of lithium? It's got 3 electrons, right?
2 and 1.
Okay, so,
in the
yeah, it's going to be 2 and then it's going to be 1. So that means there's 1 electron in the valence shell. What about sodium? Sodium is 11. So what's the electronic configuration? It's
281. 281. Sorry.
Okay, so it's 281, right? So anyways, it's all of them are going to have 1 electron. Similarly, group 2, all of them will have 2 electrons in their outer shell. So that makes electronic configuration slightly easier. You don't have to write the whole thing. I mean, you don't have to write the number of protons, neutrons, electrons. A lot of time by just looking, aluminium, it's in group 3. So how many outer electrons? That's 3. Okay. So I don't have to draw all the shells. What I'll just do is, if I'm talking about aluminium, what I'll do is I'll just draw a circle. I know that it's got 3 electrons in its outer shell. That's it. I'm going to ignore all the other shells because it's usually the outer shell electrons that are interacting with it. So remember, there are quicker ways of writing electronic configurations or knowing the electronic configuration, especially for the outer shell. I said, what information does the period tell you?
I forgot.
Like if I know that, I mean, this is period number 1. This is period number 2. This is period number 3. This one, the one that where the line is passing, that's period number 4. Then you've got 5 and 6 and so on. TK. So what information does the period tell you?
The increasing number, proton number.
No, but specifically, I mean, there's increasing proton number in a group as well. So period number tells you, remember this, it tells you the total number of shells. So it tells you the total number of shells that the atom is going to have. So for example, over here, which period is lithium in? Lithium is in period number 2, right? I mean, the first period only has 2 elements. Now lithium is in period number 2. So how many shells is it going to have? It's going to have 2 shells, right? So it's got 2 shells, 1 and 2. Is that clear? Sodium is in period number 3. So it's got 3 shells, 1, 2, and 3. Is that clear that period number tells you the total number of shells? Ye clear hai? Saron ko. Otherwise this clear. Or Shema clear hai? Achha, so the next question is how can these two things help us? Now for bigger atoms, the problem comes with bigger atoms, right? So I'm going to move towards bigger atoms now. Let's look at bromine. Immediately, what do I know of bromine? Based on its location.
Okay.
Like here's bromine. So what information do I have without writing like directly? What do I know about bromine? How many valence shell electrons does it have?
-1.
No, not the charge. Like how many valence shell electrons does it have?
7.
70. It's got 7 electrons in its outer shell, right? And how many total shells does it have?
4.
You get 4. It's got 4 of them. It's so 7 is the group number. That's the number of electrons it has in its outer shell, and it's in period number 4. That's the 4th one. So that means it's got 4 total number of shells. So bigger atoms. Remember that bigger atoms. So writing electronic as a configuration of bigger atoms. Because remember, it's going to be a waste of time. Like you figure out whether calculate the number of protons, then number of electrons, then the number of neutrons, then try and figure out, like you got 35 electrons. That's a lot of electrons. So, so writing electronic configurations of bigger atoms, and by big I mean atoms that have more than 20 electrons. So electrons are greater than 20. So let's talk about bromine. It's 80 and it's 35. It's 80 and 35. Now, although I can actually tell that it's got 35 protons and it's got 35 electrons, and it's got what's 80 minus 35? That's 45, right? It's 45. So it's in group 7, and it's in period 4. So that gives me a lot of information. It's got 4 shells. And it's got 7. I said it's got 7 valence electrons. Right, so I got all this information about bromine by just looking at the periodic table, right? Now, writing the electronic configuration of a bigger atom, how do you do that? I know it's got 4 shells, right? So 4 shells. And remember, I'm not going to do 288 because the third shell was actually 18. It wasn't even 8. So 4 shells, right? Now, don't use 288 for bigger atoms because that only applies to smaller atoms because you had so few electrons. So this is the maximum electrons that can be accommodated in that particular shell, right? The first one has a maximum of 2, the second one has a maximum of 8, 18, and then the last one is 32. How many electrons for bromine would the last shell have? It's in group 7, right? So kya hoga? How many electrons in the last shell? That's 7 valence electrons. So the last shell over here, that one is, that's 7 electrons, right? The last one. So in total, it had 35 electrons. So out of 35, if 7 are in the last shell, how many electrons in the other 3 shells? That's 28 electrons, right? Total kitne? That's 35 electrons. 7 in the last one. So the remaining shell has 28 electrons. So I have to fit 28 electrons over here. So 2 in the first one, 8 in the second one. That's how many? That's 10. And I'm left with I need to put in 18 electrons over here. Okay, that's the electronic configuration of bromine. So bigger atoms, remember that. Start from the end. Start filling the last shell. Okay, do that first. And then fill the rest of them. Okay, you already know, I'm going to break this up. You already knew that it had 4 shells, 1, 2, 3, and 4. You knew the last one, right? So fill that one first, fill that one first, and then fill the rest one with the remaining electrons. Is that clear? Ye part clear?
Yes.
And remember, there will be very few questions on bigger atoms. I told you earlier, okay, most of the atoms in the universe, the ones that you're going to talk about, they're smaller atoms, less than 20 electrons. They're the ones that are more common. Bigger atoms are less common. I'll do another example. Let's take the example of, let's try and do rubidium. Okay, that's Rb, that's rubidium. Let's try and do that. So now rubidium is
Group 1.
Let me.
Sorry.
Nee, it is group 1. Yeah, no. Rubidium is group 1, right? The numbers, that's 37 and 85, right? That's 37 and 85, that's in group 1 and it's in period 5, right? The first period is the one that's the empty one. 1, 2, 3, 4. It's in the 5th period. Okay, so अच्छा पहले तो वो कर लें 37. What is it? 37 and 85. So 37 protons. 37 are the number of electrons, and what's 37 minus 85? What's 45 plus 3? That's 48. If you have a calculator, tell me what's the exact number. That's, I guess it's 48. As anyways, it's in group 1. And it's in period 5. So I got that it's got 5 shells. So it's got a total of 5 shells. And it's in group 1, that means it's got 1 valence electron. So it's only got 1 valence electron. So 5 shells, remember that. I'm going to start off with 5 shells. That's 1, 2, 3, 4, and 5, right? And I know that the last one has 1 electron in it. And what's the maximum electrons? That's 2, 8. The third one has a maximum of 18. Then you've got the fourth one has a maximum of 32. Fifth one has a maximum of 50. 2n squared, right? But writing the electronic configuration, I'm going to start off with the last one electron. How many electrons am I left with? 36. So 2 electrons, then I'm going to fill the rest of them. 2 electrons, 8 electrons, 18 electrons. Karne kitne fill? That's I need to make it up till 36. So this is 26, 28. 2, 10, and 28, right?
That's 28.
So if I want to go up till 36, so this one will have 8 electrons, right?
28 minus 37. Yeah, yes.
So I had to fit in 36 electrons over here, right? So this is how you're going to do for big atoms. Start with the number of shells, 1, 2, 3, 4, 5. Fill the last one first because you already know that it's got one valence electron, right? So you go and fill the last one. And once you do that, so out of 37, one is gone, one is over here. So you have to fit in the 36 over here. So the electronic configuration of this rubidium is going to be 2, 8, 18, 8, and 1 in the last one. Is that clear how you're going to do for bigger atoms, TK?
Yes.
Very few questions on bigger atoms, but remember they will ask you about bigger atoms off and on. And even if they don't ask you about the electronic configuration, remember this, that by just looking at the periodic table, you can tell the number of valence shell electrons that an atom has. If something is in group 3 over here, if you're talking about boron, by looking at the periodic table, you can tell that it's got 3 valence shell electrons and it's going to have a total of 2 shells. It's in the second period. It's in the second period. So it's going to have a total of 2 shells. You be clear, right? So we'll do a worksheet now. It's this one is going to be very basic. I'll also try and see if we have 1 second. This one, let's do this one. Just 1 second. इसकी मैं कॉपी कर लूं. So let's do this one. It's I say in which I say this one, in which option do all 3 particles each have the same number of electrons? So the answer to this one is probably going to be, I'm just going to look at the number of protons. That's 9 over here, 10 for this one, and there's 11 for this one. So this one was supposed to have 9 electrons. Minus 1 means it's got 10 electrons. Neon is a neutral atom. That's 10 electrons. Sodium should have had 11 electrons, but it's got a +1 charge. So that's also 10 electrons. So all have, so in this case, all of them have, they've got 10 electrons each. So all of them have 10 electrons and it's going to be B. Is that clear?
Yes.
So then this one, naturally occurring bromine has a relative atomic mass of 80 and consists entirely of two isotopes, 79 and 81. Now, this one is about isotopes. Remember, I told you, he's saying that bromine has, I said, this is something that we did in isotopes. I told you that isotopes can have many different neutron numbers, right? The only thing common is like if I look for oxygen isotopes, right? There would be lots of them. Just where's Wikipedia? As isotopes of oxygen. So there are going to be lots of them. Okay, oxygen can be, it can have an atomic mass of 11. They can all have different number of neutrons. But the most stable one is 16. यहाँ पे उसकी percentage भी given होगी. That's the most 99. This is the proportion or range of 99%. 99% of all oxygen is 16. So when you talk about isotopes, you talk about the most relevant one. Like when you look at the periodic table, you're talking about the ones that are most common. So your periodic table में the mass that is given to you. ठीक है, here's my. Now bromine, if you remember the periodic table that we just did, it had 80 written on top of it, right? Now over here he's saying that bromine has an atomic mass of 80. That's the one that's given in the periodic table. Okay? If I go back, okay, look at bromine over here. The atomic mass is 80, right? So it is actually 80. But if you go back to the question, in the question is saying that there is no 80 actually. What it is, it consists entirely of two isotopes. One of them has a mass of 79, the other one has a mass of 81. So bromine atom is actually, there are two types of atoms. One of them is 79 and the other one is 81, right? The only difference between the two is they have different number of neutrons, right? So it's got these two isotopes. So can anyone explain to me why do they write 80 in the periodic table? Because in reality, there is no bromine 80. There's bromine 79 and there's bromine 81. Why do they write 80? Can anyone tell me what's the reason for that? Any idea? Let's say I've got a box and that box contains bromine atoms, right?
They round off.
So let's say I bought a box of bromine atoms, right? So here's this box of bromine atoms. Now there is no bromine at 80. Bromine either has a mass of 79 or it has a mass of 81. Okay. So it's like, so some of the bromine atoms have a mass of 79, some of them have a mass of 81. Like you buy apples, right? Some of the apples will be having a lower mass, some of them will be having a bigger mass, right? So I've got this box or this bag which has all these bromine atoms. So if somebody, let's say you've got a bag of apples and somebody is going to ask you what is the mass of an apple or what's the atomic mass, what's the mass of an apple? So what do? You take the average mass, right? You tell them that's approximately this much, right? वो हर की differently तो नहीं बताता ना. You don't tell them that the first apple is this much, the second one is this much. You just tell them an average mass, right? So what you do is, if you were to take the average of the mass of these atoms, it's going to come out to be 80. Is that point clear? But is that idea clear that you add them up? Average कितना लेते हैं? How do you take averages? You add 79 plus 81 plus 79 and you divide by the number of bromine atoms, right? That's how you take the average. If you were to take the average, it's going to come out to be right or exactly equal to 80. Is that clear, this part? Or why is this clear? So remember this, when you're dealing with, this thing over here, atoms can have different masses. Okay? Just like the oxygen atom, it can have many different masses because it can have different number of neutrons, right? So when you talk about the periodic table, when you talk about the oxygen atom, you just take the average. In most cases, you don't even take the average. You just take the one that's more common. Okay, 99% of all oxygen atoms are actually oxygen 16. So your bag is going to be full of oxygen 16. Your baki jo na, you'll never, your bag is never going to have them in the first place. So you're just going to take oxygen at 16. But sometimes what happens is, actually chlorine ka dekh lo. Why? Look at chlorine. Like look at chlorine in the periodic table. If you look at chlorine over here, where's chlorine? Right at the top. This one. Chlorine has an atomic mass of 35.5. In reality, there is no chlorine 35.5. When you talk about a bag that contains chlorine atoms, what happens is that chlorine ke case, what happens is that let's say a bag contains 4 Cl atoms, right? Now there is no 35.5. Actually, what happens is there are a bunch of Cls which have a mass of 35. And there's one that has a mass of 37 because it's got a different number of neutrons, right? So your bag is always going to be in this proportion, that it will have some chlorines which are 35 and some chlorines which are 37. When you take the average mass of the atom, it comes out to be 35.5. So that's why the periodic table has 35.5. When in reality, there is no 35.5. There's actually 35 or 37. Like wo jo average puchte na, you just tell them the average mass. That's approximately 35.5. Is that part clear? This one. You clear? Amna, Soeb, Abdullah, is this clear?
Yes, sir.
Chalo. Achha, let's continue tomorrow. Okay, we'll do a few more questions from the same worksheet. And then we'll move towards chemical bonding. Okay? So, okay, everyone. Take care, Allah Hafiz.